Welcome to the project demonstration of battery management system for electrical vehicles with machine learning algorithm and IoT Thingspeak. So the main features of this project is we are going to get the voltage, current and temperature of this battery pack. So this battery pack will be existed in electrical vehicles. So while we are utilizing the battery packs in electrical vehicles, there we need to monitor the three main parameters, that is the voltage and how much of voltage was there inside the battery pack. Whether it is a low battery voltage, then we need to make it charging in time, and if it's a high battery voltage, then we need to do the auto cutoff. And coming to the current, so what was the current was there, and due to the current, if the battery discharged drastically or it is discharged according to the ratings, so that reflected the SOH. So that is nothing but the state of health. And coming to the state of charge, that is SOC, when we are charging the battery pack, so if the battery pack voltage increases according to the charge ratings. For example, as you know that when we connect our mobile phone to the powerful adapter, then we may get around 1 minute around 2%. Same thing here also, we are providing the current rating of 1 amp from this charging circuit, and if the battery charger was switched on, then the battery voltage needs to be increased certain level. So if it is not reached the certain level, then the SOC will be affected, and that will be displayed and calculated on the LCD screen using this Raspberry Pi 4 by using this machine learning algorithm. Same for the SOH also. So whenever the battery is discharging the voltage, so if it is discharging the voltage rapidly, then it will affect the SOH, that's the state of health. So these two values need the voltage, current, temperature input from this Arduino Uno. As we are using the analog sensors, our Raspberry Pi doesn't have the inbuilt analog to digital converter. So there we are using the Arduino Uno to convert the analog data to serial data. So this will inform to the Raspberry Pi in serial communication, that is the voltage, current and temperature of the so-called battery pack from this one. And based on this voltage, current, temperature, our Raspberry Pi will control the relay whenever the battery voltage is less than 8 volts, and whenever the battery voltage is more than 12 volts, then automatically this relay will get switched off to protect the battery from overcharging. Same here, whenever we switch on this DC motor, the current will be measured from this one and will be converted to analog to serial to the microcontroller. So here we are using the current sensor and voltage sensor. These two are the current and voltage sensors, and this one is a temperature sensor. So here we are using the controlling part regarding the temperature. So due to the overheating of the battery pack, either over voltage or over current or any short circuit occurred inside the battery pack, before getting the fire accident, then the system system will get the temperature of this battery pack, and based on the temperature values, the system will control the cooling fan. And this was controlled by the same Raspberry Pi 4 through this transistor board. This is the charging circuit, and this one is a like cooling fan on purpose. And parallelly, same details will be uploaded to the Thingspeak cloud platform, so we can access this data from anywhere in the world. That is the voltage. So here the voltage and current and SOC, SOH values and temperature values. Total 5 wheels we are getting continuously, and this can be accessed from anywhere in the world. So like if you want to erase the old data, before erasing the data, go to data import export to download the data, make it as a backup. So download the data, so it will download an Excel sheet, and you can open that sheets. So the data consists of date and time and number of samples till now we have collected. So total 27 samples till now we have collected, and the field 1 is the voltage, current, SOC, SOH, temperature values. So total 5 fields. So after we took the backup, now we can erase that. To erase the data, go to channel settings, and in that only do clear channel, okay, and then private view. So the whole data got erased. So now before on the kit, first of all, we need to on the hotspot. So using your mobile phone hotspot only, the system will upload the data to the Thingspeak, and the system will run, because it needs internet first of all before setting up the total instructions. So now go to hotspot name and change the hotspot name to project 7098 without any space, without any capital letter. Password should be 123456789, and AP band should be 2.4 gigahertz. After we enable the hotspot along with data, log into the Thingspeak cloud platform, on the power supply to the kit. So this is a power supply for the Raspberry Pi and total electronic components, and the transformer will take 230 volts AC inputs and provide us the 12 volts of AC outputs. Right, after we switch on the power supply to the Raspberry Pi, it will take around 20 to 30 seconds of duration to boot into the operating system. So in this memory card, we loaded the legacy 32-bit version operating system. After we install that, we connected this to the HDMI screen along with the keyboard and mouse. There we write the instructions to read the serial data first of all, and then separate the serial data, voltage, current, temperature, and using the machine learning algorithm, we are going to estimate the battery life in SOC and SOH values that will be displayed on the LCD screen. So welcome message is displayed, and then it will try to connect the internet, and it will be connected to the internet directly. The values are received from this microcontroller, this Arduino Uno. We can see the light blinking on this one. It's continuously sending the data through serial communication to our Raspberry Pi 4 model we are using. So the battery voltage is 12.26, which is sufficient. As of now, everything is normal and the current is 0 as we are not on this load. And the next temperature is 33.0. So everything is normal. Let us make the high temperature. So the high temperature due to anything like high voltage or high current or any short circuit occurred inside the battery pack or heavy load. So whenever it crosses 45 degrees centigrade, then automatically the audible alert will provide us the alert and the same message displayed on the LCD screen, and we'll get the cooling fan gets switched on to make the battery pack cool down. So this may affect the SOC also. We can see that the SOC will be affected whenever the temperature increases. And the next, on this load, now we get the load of 0.15 ampere of current, and in the Thingspeak, the data is continuously storing. So it will take around 15 to 20 seconds of duration to be uploaded into the Thingspeak cloud platform. Right, okay, and current is 0.15, 0.12, it will be varies. And in order to make the low battery voltage alerts, so we can use low voltage batteries inside this battery pack. So the battery pack voltage ratings is 12 volts of 1200 mAh of battery pack we are using here. So in this battery pack, 3.7 volts 1200 mAh of batteries are connected in series. So we will get 11.1 maximum of 12.5 volts when these three batteries are fully charged. So in order to make the low battery voltage alert, just we place a switch here. This is the current, means to on and off the load directly, and this is the voltage sensor purpose. Just we are make the fault manually by disconnecting the battery pack to the voltage sensor. So the voltage sensor measuring the battery voltage of 0, then a microcontroller informed to the Raspberry Pi about the battery voltage levels. So whenever the battery voltage is low, means less than 8 volts, then low battery voltage message alert on the LCD, and relay got switched on already. So we can see the relay status also. So the relay got switched on. So whenever everything is normal again, so the relay will be off as the battery voltage is more than 12 volts. So it will be off condition, means it's protect the battery from overcharging. Coming to the main components here, so we are using the 230 volts AC input to the transformer, so which will step down the 230 volts AC to 12 volts of AC. The 12 volts of AC is output from the transformer to this regulated power supply board, so which will take 12 volts AC input and provide us the 12 volts DC output, that is the charging voltage of battery pack through this relay. Okay, and the relay is in series with the input power supply to the battery pack, and the same the battery pack voltage is connected to the voltage sensor and current sensor to the load, and this Arduino Uno interfacing between the sensor parts and Raspberry Pi, and relay is connected to the Raspberry Pi directly, and buzzer also connected to the Raspberry Pi, and the 16:2 LCD screen connected to the Raspberry Pi pin number 17, 27, 22, 9, 10, 11 pins, and 5, 6 pins are connected to the relay and this CPU cooling fan here, this temperature cooling fan here. And the next receiving pin of our Raspberry Pi is connected to the transmitting pin of our Arduino Uno board, and A0, A1 pins are connected to this voltage and current sensor, and temperature sensor is A2. So these are the main interfacing connections of input output modules, and buzzer interface at the pin number 22.